In this video, we're going to learn how to name and write formulas for oxyacids. So remember that binary acids contain only H and their nonmetal along with AQ. Binary acids contain H and the nonmetal along with AQ, whereas oxyacids, they have H and a polyatomic ion containing O. So it's more than one element in there. Regardless, they still have the AQ as well. We saw how to name compounds, binary acids before, and for binary acids, they always started with the prefix hydro. So for example, HCl was HCl, so HLAQ was hydrochloric acid. Now, when it comes to oxyacids, if you want to name those, they're very similar to how you would name the binary acids. It's just that you don't put the prefix hydro. So we no hydro prefix in their name. So what you have to do is you have to look at the polyatomic ion that you're dealing with. So this is ClO3. I would go to my reference chart and I would see that that is chlorate. And what we see is that if you have a polyatomic ion ending in 8, you make it ICE in the acid name. So this would simply be chloric, no hydro in the front because it's not binary, and then acid. Chloric acid. Suppose we had HClO2 AQ. Once again, you would recognize this is not binary, it's an oxyacid, so there's no prefix hydro. The only thing is that you'll notice that this polyatomic ion here is named chlorite, ITE, not ATE. So if you have a polyatomic ion ending in ITE, the ending for the acid name becomes OUS instead. So chlorate or chlorite becomes chlorus. So this is chlorus acid. Chlorus acid. We're going to try naming a binary and an oxyacid side by side just to see that difference once again more clearly between the two so you don't make the mistake. So here we have H2SAQ, and here we have H2SO4AQ. Let's start off by identifying the binary one. You'll notice this is a binary one over here because there's only 2 elements. Since it's binary, we have to put the prefix hydro, and we change the ending sulfur to sulfuric. Hydro, sulfuric, and then acid. Now here, notice that we have an oxyacid because of the polyatomic ion in there. So we wouldn't use the prefix hydro. This is the polyatomic ion sulfate that ends in ATE. So this is going to become sulfuric acid. Very similar in name, but this has hydro in the front and this does not. No hydro. So now we're going to take a quick look at how to go from the oxyacid name to the oxyacid formula. So here we go. We have sulfurous acid. From this name, we know it's going to be an oxyacid because there's no hydro in the front. No hydro. So what we're going to do is we're going to write the H first as +1. And we have to figure out which polyatomic ion this is. This is either going to be sulfate or sulfite. So notice how the ending is OUS. Because it's OUS, this means we're dealing with the sulfite, the ITE. It came from the ITE version. Sulfite is simply SO3 with a -2 there. Then you can crisscross. And you get H2 SO3 1. You don't need the 1 anymore, so you just write H2 SO3, and you can put AQ because it is an acid. So that's sulfurous acid. Let's try the following ones. You can pause the video and try them out yourself. So nitric acid. We'll then name this one here instead. and then you'll write the formula for this one here. So nitric acid. Nitric acid, this is not a binary because there's no hydro in the front. Nitric means that IC means that this was 8 before. So that's nitrate. So this comes from nitrate. So we have H plus 1. Nitrate is NO3 minus 1. You can crisscross it and you get H1 NO3. You don't need the ones there anymore and the bracket there. So we have HNO3. And don't forget AQ. This looks very similar, this one over here. Notice it's not binary, so no hydro needed. You have to look at what the identity of this is. This is NO2. If you look in your chart in your reference table, you'll see NO2 is nitrite. So because NO2 is nitrite, when you're naming this acid, the ITE becomes OUS. So nitrous acid. Lastly, we'll do carbonic acid. Carbonic. IC, that means that was from carbonate. This is not binary because there's no hydro in the front. So we're going to have H plus 1, carbonate, in brackets CO3 minus 2. Crisscross those and you get H minus 2 brackets CO3 plus 1. We can drop the signs, H2 CO3 1. We no longer need a 1 on the outside, and the bracket can be dropped there as well. So HCO3, and then don't forget, before you finalize or to finalize, we got an AQ there, and that's carbonic acid. So in this video, we saw, again, how to distinguish between binary and oxyacids with formulas, but also by their names. We saw how to write the names of an oxyacid from its formula, and then we saw how to go from the name to the formula, and how to identify that you have an oxyacid from the name by realizing that there's no hydro there. We also saw that when you're naming or writing formulas for oxyacids, the main challenge is figuring out if you're going to end it in ic or us, and that depends on what the polyatomic ion was named. If it's ate, go to ic. If it's us, go to ite. Or if it's ite, go to us.